Alright, so you should have a scatter plot made. Yes? Okay. So your scatter plot should look like that. Okay. Logistic? Do we agree that it's logistic? Okay. My guess here is that it probably came from down here. It grew exponentially, and then now it seems to be leveling off, right? So in order to make a logistic function of the form f of x equals c over 1 plus ab to the x form, what three values do we need? Okay, what's our upper limit? Our upper bound, what is it? I don't know. What do you? The inflection point would be about halfway to the limit. So where it changes from growth to a decay, so that would be somewhere back over in this general range right here, right? Okay, that's one way. Another way is if you have enough data and like this last part's kind of leveled out already, so that means it's probably almost at the maximum. Okay, so what do you want to go with as a C value for our upper limit, our upper bound? 100 would be way off the graph. It'd be up above the ceiling. 13? Yeah. 13 sound good? Okay, all right, let's go with 13 then. Last class actually went with 12.7. Okay, but that's fine. 13's fine. Okay, all right. Now what? What do we find next? The initial value, no. A or B? A, okay. How do I find A? Look for the initial value, right? Yeah. Okay. What was our initial value of our data? That was this data point right here, right? Okay. That was where x was equal to 0. Okay. So how did we use that yesterday when we were making logistic functions?
You put like 6.3 on the you put 6.3 equals 13 over 1 plus a, and then
because really it's ab to the x, yeah. But x is 0. Yep. Okay. So just for this purposes, I'm going to go like that. Okay. But really, okay. 1 plus a there. Okay. Then what? Okay. Then what? Do we have to? Just divide by 6.3. We could distribute and go through it that way too, but yeah, we can just divide by 6.3. And then what? Subtract 1. Okay. So then that value is divided by 6.3 minus 1 is 1.06349. Okay, good. I like it. Now what do we have to find? B value. Okay, so which which data point do we want to use to help us find the B value? You guys tell me when to stop. That one? What if I would almost go one more, because these are kind of like in a line over here. So I'd go to one of those end ones. So you want to go to this one? That one? So that is 10, 20, 30, 40, 50, 60, 70. That one? Okay. So do it the exact same way here. 11.8 is going to equal 13 divided by 1 plus A. A is going to be in my calculator here momentarily. Times B to the what power? 70th power. Okay. So let's make sure that we have A in our calculator. Store as A. Because then we, oops, syntax error. The A never showed up. There's A. There's A. Okay. All right. So A is stored in there. So then again, cross multiply. Again, divide by 11.8. Again, subtract 1. Then I'm going to divide by A. That cancels that out. And I'm going to take that to the 70th root to cancel that out. Okay? And I'm going to do all of that on my calculator. Okay? So I need the 70th root of 13 divided by 11.8 minus 1 on top and then A on the bottom. And I am going to store that as my B value. 0.967023. Okay? So my logistic function then is the population of Pennsylvania is going to be equal to, we said 13 over 1 plus 1.06 times 0.967 to the x power. Approximate, around it there. Okay? Let's throw that on our graph and let's see how it fits. Venue, function, it will be a fraction, and it will be 13 on top, and it will be 1 plus a times b raised to the x power. Not bad. Not bad at all. Huh? What would the maximum sustainable population of Pennsylvania be according to our model? According to our model, what's the maximum population of Pennsylvania? What do we got?
I forgot what exactly the measurements were on the slide, but it's like 13,000.
13, probably millions would be my guess. Yeah. Okay? Yeah. All right? Yeah. It's a lot of people in one little state. Okay? All right? Now, first off, I want to graph it. Okay? All right? Should be relatively easy to do, right? Because it's logistic, correct? It's a logistic growth. How do I know it's a logistic growth? The b value here is between 0 and 1. So since it's a logistic growth, it's going to look like that, right? Yes? Okay. So I've graphed it. Now I just got to fill in some points. For instance, I need to fill in what is my lower horizontal asymptote. Y equals 0 is my lower horizontal asymptote. What is my upper horizontal asymptote? Y equals what? 8 is my upper horizontal asymptote. What is my y-intercept?
Zero comma 2.
0, comma 2. Do we agree with 0, comma 2? I have to put in 0 there, right? So that becomes 8 over 1 plus 3 times 0.7 to the 0 power. Anything to the 0 power is 1. So this is 8 over 1 plus 3. 1 plus 3 is 4. 8 divided by 4 is 2. 0, comma 2. I agree with that. We're only missing one little thing. There's our graph. Okay? You graph that one. There's the graph. Oops. There's my lower bound. There's my upper bound. Now I just got to figure out what they are. Lower. 0. Upper. 20. Then I just have to figure out my y-intercept. So I'm going to put in 0 there. So that's going to be 20 over 1 plus 2 e to the negative 3 times 0. Negative 3 times 0 is 0. E to the 0 power is 1. Times 2 is 2. So I get this here is 20 over 1 plus 2. So that's going to be 20 over 3. So my y-intercept here is the point 0, 20 thirds. Okay. Fantastic. All right. So, Dallas, Texas has population growth that is slowing. A logistic model for the population of Dallas in the T years after 1900 is given by that function P of T. Okay? What I would like you to do now is I would like you to find what Dallas's population was in 1950. What am I trying to find here? P of 5? P of 50. Okay. So that's going to be 1301642 divided by 1 plus 21.602 e to the negative 0.05054 times 50 power. Correct? And I get that. But really, that is what it is. Okay? It just rounded it to a whole decimal or a whole number for me. Okay? So I get 477,498. $477,498. Yep. Okay. So we get that many people in Dallas in 1950. Okay. All right. Next question. Using that same model, when did or when will the population of Dallas exceed 1 million people? I'll bring that function back into play. There it is. Okay? So when did or when will that population exceed 1 million people? Find that for me now. Give me one method that you use to solve this one when it's a million, when Dallas made 1 million people. What do you got? Overall, how did you solve it? You solve it algebraically, graphically, guessed?
I did it algebraically.
Okay, I'm going to wait on that one. Did anybody graphically solve it?
I attempted to.
Okay, how would we go about graphically solving it?
Well, I don't know if it
Didn't work the way you did it? Okay, so help her out. How could have she graphically solved it? Graph this equation. Did you put t in your equation? Okay, all right. So you graph this equation, and then what other equation do you graph? Y equals 1 million, or f of x equals 1 million. Yep, and then you see where they intersect, right? Okay, so I got them intersecting at 84.5. Okay, so that's 84.5 years from 1900, right? Okay, so that's one way of doing it. Algebraically, if we solve it, okay, so then we would say 1,000,003 equals 1301642 divided by 1 plus 21.602 e to to the negative 0.05054 x power. Right? And we got to solve for x. So, algebraically, we would solve that one by, we would take, and I'm going to do this right on the calculator. So I would take 1301642, divide that by 1,000,000. I think that's 1,000,000. Yep. Okay. So there's that. So I've moved this, so I've cross multiplied and I've divided it. Then I've got to subtract 1 from that. Okay? Then I've got to divide that by 21.602. Gets me that. Okay? So that now is what E is equal to. So I take the natural log of that. So that's what my exponent is now equal to. And then I divide that by negative 0.05054. Gets me that. Okay? So either way, we should have gone with 84.5 years. So 84.5 years, so that would be sometime in June of 1984. Right? Okay. All right. Last question for you of the day. What is Dallas's maximum sustainable population? What's the maximum sustainable population of Dallas?
1,301,642.
That upper limit, that C value, is the maximum sustainable population. Okay? Have yourselves a great, grand, and wonderful day.